Today's seminar is going to cover solving 1, 2, and multi-step equations. And the goal of this seminar is going to be I can solve 1, 2, and multi-step equations. So please make sure that you get this put into your notebook, and hopefully by the end of this lesson you will be able to solve 1, 2, and multi-step equations, or you'll be progressing towards meeting this goal. So let's jump right in. So when solving equations, basically what we're doing is a bunch of inverse operations in order to get a variable by itself. And some of the inverse operations that I have listed here, are addition will be the inverse of subtraction, and subtraction is the inverse of addition. Multiplication is the inverse of division, and division is the inverse of multiplication. And we won't see this much within our courses, but if I square something, in order to undo it, I take the square root. And if I want to undo a square root, I would square it. So these are the inverse operations that we apply to our equations in order to isolate a variable or get it by itself. And as I have listed up here, inverse operations are operations that undo each other. And I have just explained those below. Another important part of solving equations is recognizing where addition is, where subtraction is, where multiplication is, and where division is. Now, division is pretty easy to spot. It typically looks like a fraction, and like we have up here, multiplication would undo that. But recognizing addition, subtraction, and multiplication can sometimes be tricky. So if we look here first at recognizing addition, it's just going to be a positive number by itself. So here I have x plus 3. I would know that this 3 is positive because the sign in front of it. And I could also write this as 3 plus x, where the 3 is also positive. But remember, we don't write the plus by it because we know that it is positive. We don't need to do that. With recognizing subtraction, we're also looking at the term with a negative sign in front of it. So if we add something like x minus b, I know that this b is negative because of the sign that is in front of it. Same thing here. Negative b plus x is the same expression, but since the negative sign is in front of the b, I know that this b is negative. And recognizing multiplication isn't super hard to recognize most of the time. It's just a number and a variable side by side. So here I have b times x, but we could have any number in there like 2, 3, negative 5, whatever it is. One important thing to remember with what sign does my variable have or what sign does this number have is that it's going to take the sign that's in front of it, just like we looked at when we were doing combining like terms. So that concept is showing up again even when we're progressing to harder topics. So keep that in mind, that it's always going to take the sign that's in front of it. And that will signal, well, do I need to use addition to undo subtraction? Do I need to use subtraction to undo addition? You have to pay attention to your signs. And listed at the bottom here of this note sheet that will go in your notebook is, in essence, what you're doing when you're solving equations. You're working through order of operations backwards. You're undoing things. Undoing your operations, should be more specific. So I would undo any parentheses first. I would undo any subtraction first. Undo any addition. Now remember, these could be interchangeable just like they are with PEMDAS. It just depends on what it is. Are you undoing addition with subtraction? Are you undoing subtraction with addition? It all depends. So you don't need to stick strictly to doing subtraction, addition, division, multiplication. These are all interchangeable just like they are with order of operations going forwards. So I'd undo any subtraction or addition, undo any division or multiplication, undo any exponents, and ultimately undo any parentheses. So you're working through it backwards. Instead of PEMDAS, it's SADMEP, which you may have heard before. So when solving equations, I would reference the sheet so that you know what inverse operation that you need to use, and looking at what's down here by picking out, well, what's addition, what's subtraction. This will be very helpful to you, so be referencing this. Something else that I'm going to give you is this, I guess we can call it a foldable that will go in your notebook, and this will guide you through the steps of solving equations. So you're going to read, these will be your steps that you'll be following, these 6, and by following the yes and no flaps that are in here, you should have no problem working through a problem that we have. Okay, so whatever the problem is, this is going to be your guide. And we will use this when we get into some of the examples here in a second. So let's jump into examples then. So you should have received this when you picked up your notes and everything for today's lesson. And what we're going to do is work through the odd number problems together, and then before you move on to fixing your entry slip, I want you to do these even number problems. So in total you'll be doing 4 problems on your own. And I do want you to incorporate the use of this when you are solving them so that you are on the right track and you know what steps you need to take, and gradually you might not need this, but this will be a great reference like I said. So I'd like you to do your work on these pages that I gave you here, your practice problems. However, I'm going to do them on a separate sheet of paper so that it's bigger and we can see what's going on a little bit better. So let's start with problem 1 here. So what we have is n minus 2 is equal to negative 15. So by solving for this variable n, we'll be finding out what number I need to put in place of it in order to balance this equation on both sides. Remember, an equal sign is figuring out how does the left side balance the right side. Equal sign does not mean find the answer. So let's go work through this one here. Looking at our foldable that we have. It's going to zoom in here a little bit. So it says, look at the equation. Are there any grouping symbols like parentheses or curly brackets? Well, looking at this one, no. So I'm going to open up to this flap here. It says there are no grouping symbols. Go to the next step. So let's do that. It says, look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? Well, I don't see anything that's the same. I can't put together n and negative 2 because they don't have the same variables, exponent or exponents, and negative 15 is just by itself. So this one I would also answer as no. It says each side of the equation is simplified. No terms can be combined. Go to the next step. Do you have variables on both sides of the equal sign? No, I don't. I just have n on the left-hand side. So I'm going to flip to no. And it says, the variables are only on one side of the equation. Is that true? Yes, n's only on the left-hand side. Go to the next step. So here it says, do you have a constant added or subtracted on both sides of the equal sign? Well, no, I only have it subtracted on the left-hand side, and negative 15 just stands on its own. So let's go ahead and flip this open. It says the constant values are only on one side of the equation. Go to the next step. Actually, I'm sorry. We do have constants on both sides of the equation. So we're going to go backwards here. So I have a negative 2 and a negative 15. Those are constants. So I'd answer this one as yes. It says choose the constant that is on the same side as the variable. So we're choosing negative 2. Undo that constant by adding the opposite to both sides of the equation. And they give an example here that 7 equals 5x minus 3. It says add positive 3 to both sides of the equation. So they would just be adding 3 to the right-hand side and the left-hand side. So let's go ahead and add this 2 to both sides, and we're adding the 2 because it's subtracted currently. It's also a negative 2, so in order to undo it, I want to add 2. I'm also going to throw in this line through the equal sign to separate what we're doing on both sides of the equation. Now, I would highly recommend this because it helps to organize what's going on. So let's rewrite what we have then. So 2 and negative 2 are going to cancel, so those are gone. I'm left with a positive n on my left-hand side. My equal sign can come down. And I would then do this operation here. So negative 15 plus 2. Oh look, there's your integer operations again. Those will pop up as long as we're doing math. Negative 15 plus 2 would give me a negative 13. Now let's continue progressing through our foldable here. Since we've done all that we can so far, it says, does your variable have a coefficient other than 1? Well, in this case, it has a coefficient of 1. We could put that in there. So we would answer no. So it says, the variable has a coefficient of 1. Go to the next step. It says you should have a simple equation with a variable equal to a number. That's what we have. We currently have n equals negative 13. And check your solution by substituting the number into the original equation. And we're going to go ahead and do that. Do the check. So wherever we see an n in the original problem, we're going to put in a negative 13. So if I would rewrite this, it would say negative 13 minus 2 equals negative 15. Now a negative 13, and I take 2 more away, would give me a negative 15. And is it true that negative 15 equals negative 15? Yes, it is. So that one checks out. Now I know a lot of you don't like to check your answer after you've solved it, but this is a foolproof way to check that you did the right thing. So take the extra 10, 15, 30 seconds, whatever it is, to check it. It will ensure that you have your answer correct. So please be doing the check as well. So that's problem number 1. Let's move to, and by the way, this was a one-step equation because all we had to do was add 2 to both sides. We didn't have to do anything else. So let's look at problem number 3. And looking at the foldable again here, look at the equation. Are there any grouping symbols? No, we currently don't have anything that we need to do here because there are no grouping symbols. And if you recall, it said go to the next step. So let's look here. It says, look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? Well, no, because this is negative 14n and this is 196. This is a constant and this is a number with a variable. There aren't any like terms, so we can't combine anything. So we would say no again, using our flip book. It says each side of the equation is simplified. No terms can be combined. Go to the next step. Do you have variables on each side of the equal sign? Well, currently no. We just still have them on the left-hand side, so we don't need to worry about that. So we would say no. So the variables are only on one side of the equation. Go to the next step. And it says, do you have a constant added or subtracted on both sides of the equal sign? No, we don't have anything added or subtracted to either of these. This is signifying multiplication right here, a number next to a variable. If you recall this sheet, number and variable are side by side is multiplication. So that one is also no. It says the constant values are only on one side of the equation. Go to the next step. Does your variable have a coefficient other than 1? Yes, currently it has a negative 14 as the coefficient, so I would say yes. So it says, undo the coefficient of the variable by doing the opposite operation. So currently we have multiplication, so we're going to divide. So it looks like this here, this 3x equals 12, and they divided by 3 there. In this case, we're going to divide by negative 14. Remember, it's going to take the sign that's in front of it. So if I were to do 196 divided by negative 14, I would get negative 14 as my answer, because negative 14 times negative 14 is 196, and we'll show that in the check here real quick. Let's look back at our foldable though for a second. It says you should have a simple equation with a variable equals a number. Variable equals a number. We have that, so we've met that requirement. Check your solution by substituting the number into the original equation. So let's do that. Let's do our check again. It's our discount double check. So negative 14, there's multiplication when there's a number next to a variable, so I'm substituting this in. So negative 14 times negative 14 equals 196. Well, I know that squaring 14 or a negative 14 would give me 196, so therefore 196 is equal to 196. It checks out. That took me an extra 5 seconds to check that, okay, maybe a little bit more, but there's value in checking your answer, so please do that. And let's take a peek at number 5 here. So let's work through the foldable again. So look at the equation. Are there any grouping symbols? Oh, and I should mention that this is a two-step equation. We have p plus 2 divided by 9 equals 3. This is going to require two operations, two inverse operations, in order to get the variable by itself. So let's look at this again. Look at the equation. Are there any grouping symbols like parentheses or curly brackets? No, there's not. So we go to the next step. Look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? Well, no, there's not. We can't do anything with this 2 and 9 yet, because this quantity here, p plus 2, we can't break that up by itself. So this answer we would say no, because there's nothing we can combine here. Do you have variables on both sides of the equal sign? No, I only have a p over here on this side. So we can't do anything there. So moving down, do you have a constant added or subtracted on both sides of the equal sign? Well, currently we do, but we can't break this up yet because there's something else we need to do first. So, looking back here, we have to go through our order of operations backwards, SADMET. Okay? Well, we can't undo this subtraction yet, this addition, I'm sorry, because we need to get rid of this 9. So, what we're going to need to do is, in this case, just give me a second here. We need to get rid of this 9 first. And this 9 is currently divided. Okay? So sometimes we don't follow this rule completely, but in order to get this variable alone, we have to do something with this 9 first. So what we're going to need to do is, since it's divided by 9, I'm going to have to multiply by 9 over 1 on both sides. And we'll make this a 3 over 1 too. I need to multiply by 9 on both sides in order to get these 9s to cancel, because I can't solve for p if there's something in the denominator here. So those cancel. So if I were to go back and rewrite this equation again, and I should drop in this line. So I've undone division with multiplication. So on the left-hand side, I should be left with p plus 2. And that's going to be equal to, now we need to carry out this multiplication here. 3 times 9 is 27. Okay? Well, now this gets us back to an equation where we can use our foldable again. So, we don't have grouping symbols. There aren't like terms on the left and right side. Do you have variables on both sides? No, we don't. P is currently only on the left-hand side. Do you have a constant added or subtracted on both sides? Yes, we do. We have a plus 2 and a plus 27. So it says choose the constant that is on the same side as the variable, so the p plus 2. Undo the constant by adding the opposite to both sides of the equation. So if I add the opposite, it's just like doing the opposite or inverse operation. So I have a plus 2, so what that means is I need to subtract 2 from both sides. So the 2's will cancel each other out. A positive 2 and negative 2 cancel each other out. So P would be equal to 27 minus 2 is 25. Now we come back to our foldable here. It says you should have a simple equation with a variable equal to a number. We have that. We have P equals 25. Check your solution by substituting it into the original equation. So wherever I see a P, I'm going to put in a 25. Let's do our check here. So I would have 25 plus 2, and that's divided by 9, and that should be equal to 3. So we need to do our order of operations here. So we take care of the 25 plus 2 first, 27. Put the divided by 9 back in, equal to 3. 27 divided by 9 is 3, so we know 3 is equal to 3. That answer checks out, and we know that we found the correct solution, that B should be 25. So that's a two-step equation involving multiplication to undo first. We had to use multiplication to undo division first. Now sometimes you have to do division to undo multiplication. And that's in one of your other examples that you'll be practicing. So that's number 5. Let's move to number 7. I'm just going to zoom out here a little bit. Perfect. And let's use our foldable again. So it says, look at the equation. Are there any grouping symbols like parentheses or curly brackets? Well, yes, we have b plus 4 in parentheses. So what that says is, use the distributive property to multiply the number outside the parentheses by every term inside the parentheses. So this is exactly what we were working on last week. We need to distribute this negative 10 to the b and the plus 4. So negative 10 times a positive 1b would be a negative 10b. Negative 10 times a positive 4 would be a negative 40. And I'm just going to draw my line in here. And on the other side of the equal sign, we still have 24 plus 6b. So we've taken care of that. We've done the first step. Now it says, look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? Well, from looking at this, I can see I have a negative 10b here and a 6b here. So what does it tell me to do? I answered yes. It says combine like terms on the left side of the equal sign. Combine like terms on the right side of the... Okay, so we can't do this quite yet. I misinterpreted this. So currently this one would actually be no. This is no. We didn't have any b's on the left-hand side that were the same to combine. and we didn't have any other b's on the right hand side to combine. So let's backtrack here. This one is actually no. The only way this would happen if I had like a plus 3b here as well. So then I'd combine those to make 9b. So that one's actually no. Here's what I was actually doing. So do you have variables on both sides of the equal sign? And in this case, yes. We have a negative 10b and a positive 6b. So what do we need to do here? What does it tell us? It says choose the variable with the smaller coefficient, undo that variable by adding the opposite to both sides of the equation. And they give you a problem here that 3x plus 2 equals 4x minus 1. It says add a negative 3x or just subtract 3x to both sides of the equation. Now it doesn't matter what you do here. I could move this 6b over, or I could move this 10b over here as well. It just depends if you're going to work with positive or negative numbers. It would do the same thing. So in this case, what I'm going to do is I'm going to subtract 6b from both sides. I just as well could have added 10b to both sides and got the same answer at the end. So after we do this, what we should get is negative 10 plus a negative 6 would be a negative 16b, and this minus 40 is still here. The 6b and the negative 6b cancel, so I'm just left with 24 on the right hand side. So we've taken care of that step. Now moving down, it says do you have a constant added or subtracted on both sides of the equal sign? Well, yes, I have a negative 40 and a 24. So what does that tell me to do again? Choose the constant that is on the same side as the variable. Undo that constant by adding the opposite to both sides of the equation. And they give you that example again. So on the variable side, I have this constant of negative 40. Now remember to look at the sign that's in front of the number, so you're doing the correct inverse operation. So that's subtraction, so I need to do the inverse operation, so I would add 40 to both sides. And then rewrite our equation with what we have. So a negative 40 and a positive 40 cancel. Those are gone on that side. We have negative 16b, and that should be equal to 24 plus 40, which would be 64. And this is where we're at so far. So let's use our foldable to work through this again. So does your variable have a coefficient other than 1? Well, yes, it does. It has a negative 16. So let's see what it tells us to do. Undo the coefficient of the variable by doing the opposite operation. So in this case, we have multiplication because of the number next to the variable. We need to use division to undo this. So I need to divide by a negative 16 on both sides. And after we do that, we should have b by itself. That's what we're trying to do. We're trying to get that simple equation of a variable equal to a number. So b would equal, I believe it's negative 4. If not, we'll find out when we check the answer. So going back to the foldable, it says you should have a simple equation with a variable equal to a number. Check your solution by substituting the number in the original equation. Let's do that real quick. Just going to grab another piece of paper here. So if I'm checking this, this would be my check. So wherever there's a b, I'm going to put a negative 4. Negative 10 times negative 4 plus 4 is equal to 24 plus 6 times negative 4. So now we need to go through our order of operations. So parentheses first. Negative 4 plus 4 would be 0, and that's multiplied by negative 10. Writing all my steps down again. So on this left side, I know I'm just going to have 0, and that's going to be equal to 24 plus 6 times negative 4 would be a negative 24. So 24 plus negative 24, or 24 minus 24, it's the same thing, should be 0, which means 0 is equal to 0. So that one checks out. So as you can see, even with the longer problems, the check takes 20 seconds. So please be checking your answers to make sure that they're right. It's a foolproof way to double check your work. Alright, so those are our 4 examples. And what I'd like you to do next is to, on your own, work on problems 2, 4, 6, and 8 and see if you can get the correct solution by getting the variable by itself, getting it set equal to a number. I would pause the video here and try these, and then I will put the answers to them up, and you should be able to see those once you hit play again. So go ahead and try those. Okay, so you should have done the problems 2, 4, 6, and 8. See if I can zoom out on these so you can see everything here. So it looks like your solution to 2 should have been 6. Your solution to 4 is negative 15. Your solution to 6 is 24. Leave those up a second for you to check them out. And your solution to number 8 should have been x equals 2. And then when I check that out, I see that 12 equals 12 on both sides. So that has been our seminar on solving 1, 2, and multi-step equations. Remember, your goal for today was I can solve 1, 2, and multi-step equations. So hopefully after watching this seminar, you completely understand how to solve 1, 2, and multi-step equations, or you're progressing toward meeting that goal. Please make sure that this sheet, this foldable, and your practice problems all get put into your notebook so you can refer to them. Also, please, 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 I can't stress enough that you should be using this foldable to help you solve equations. It's a great way to remember the steps and organize it, and also be referring to this inverse operation sheet. Because remember, thinking about solving equations, it's just a series of inverse operations to help us get the variable by itself. If you have any questions, please feel free to ask me. This concludes the seminar.